so often they don't get very fair ratings. So that's one approach. The other approach is a scientific one, where you measure the boats, you try to model the performance, and you try to predict in some way how this boat's going to perform on the race course. And can everybody understand me okay? You can hear, okay. So what ORC uses is what's called a Velocity Prediction Program, VPP. And it's a very complex formulation that measures the sails, the spars, the mast, the boom, the boat itself, and a few other things. Runs it through a program that tries to model, based on those measurements, how fast this boat will go in different wind speeds and different wind angles. And the basis of an ORC certificate is telling you how fast this boat will go in these different conditions. It's not an easy thing to do. The other approaches that you use are whether you do this in secret. If you do it in secret, then you tell your audience, hey, look, we know what we're doing. You don't worry about it. Don't bother with the details. We'll take care of it. And most intelligent people don't like to be told that, in my experience. They want to know what's behind the curtain, right? It's like the Wizard of Oz. Somebody in the back behind the curtain is driving the show, but so secrecy is an approach that is necessary in some systems because they don't have a sophisticated, complex way of measuring or predicting the boats, because this is not an easy system when you do it. They prefer a simple system, but that simplicity has to be managed by people. So they intentionally keep these systems secret. An open system like ORC, however, is fully published. If you want the VPP, you can buy it. It's 300 euros, 500 euros. Is that right? 500. You can buy the program. You can run test certificates. If you change something on your boat and you want to see how the rating will differ, you're open to do that. So it's an open system. It's like open source in the computer world, computer developers world. The theory being that the more open it is, the more it's open to input. So if somebody says, you know, that doesn't really work, how can we improve? How can we make this system better? And this is the ORC approach. What is ORC? What is this acronym? Offshore Racing Congress. As an organization, we've been around since 1969. Prior to that time, the English had a system, the Royal Ocean Racing Club, and the US had a system that was done by the Cruising Club of America. And in 1969, they decided that the world needed an international system, so they formed the ORC. And since then, ORC's been doing a system called IMS. Prior to that, it did a system called IOR. Maybe some of us are old enough to remember IOR. What was it? There were championships here, right? Back in the IOR days? Different ton classes and so on? Yeah. So this was an international system that was universally accepted. And then now the system has grown, as we showed before. All right. The system works based on measurements. We need to have data. We need to know what the boat is. The more we know about the boat, the more accurate the rating will be. Now, here's Signore Nicola with his favorite tool, the total station, or maybe that's not your favorite tool. Laser cloud, maybe. This is a method of determining, one of the things we need to know in the ORC system is the shape of the hull. The shape of the hull, the shape of the keel, the shape of the bulb, the shape of the rudder. We rely on a digital representation of the three-dimensional shape of those underwater profile of the boat. So I'm looking out here at the boat here. Keel, rudder, underwater profile. Those are all in a digital file. That's very important because that describes what of the boat is going through the water. And the hydrodynamics in the VPP need to know that. So how do we get that? Like Nicola, he can use a total station, get this in a manual way with a laser. That's fairly expensive and time consuming, but very accurate. Most of the time, however, we get these digital files of the boat from the designers. The designers use CAD systems, right? They're doing everything digitally. The boat builders are using digital systems to do the lofting and the production. So we normally use the digital files from the designers and the builders, and then maybe with a few checks to make sure they're correct, we have that. So for you as boat owners, it's pretty rare, unless you had a very unusual kind of boat, that you would need to go through the process, excuse me, of three-dimensional hull measurement. That's not too common anymore. The other thing that's unusual about ORC is this photo here, taken of a boat that's going through an exercise called inclination. It's a stability test. We want to know how stable the boat is. So why is that important? Anybody want a Seahorse magazine who can answer that question? Why is stability important? What point of sale does stability have the most effect? Not Nicola. He cannot answer this. Anybody?
Upwind.
Who said that? Upwind. Sorry, I thought that was Nicola.
Thank you.
Sorry. Upwind. The more stable the boat is, by having a deeper keel, a heavier keel, more crew on the rail, makes a boat faster upwind, doesn't it? Therefore, we need to know in our measurements how stable the boat is. And the test for that is this stability test. It's an unusual exercise. It has to be done in a careful way, but it's an accurate representation of the stability of the boat. In some cultures like Australia, it's also used as a criteria for determining who can sail in offshore races. They have to have a minimum stability. You don't want tippy boats going out there and doing the Fastnet race, for example, or the Newport Bermuda race. So we have a way of measuring that and putting a number to it. So these are important differences that ORC has relative to other systems. That's a three-dimensional representation of the hull, XYZ space. This is what it looks like. This is what's called an offset file. If anybody's ever been a boat builder, they know what that means. It's simply the dimensions of where on these transect lines through the hull, of where the distance of the hull is away from a center line. Okay? Now, why is this important? It's important because if you have the three-dimensional profile of the boat, you can do a simple measurement of the freeboards. So, at this place here, to the water plane, you measure that, and if you measure here, at the bow, down to the water plane, and you know what the three-dimensional profile of the boat is, you can calculate what? Weight, exactly. Archimedes' principle, displacement. Trim flotation, you can understand a little bit about how, depending on what the relative freeboard is forward and aft, because you need to take it in two places. Then you can understand a little bit about trim. But these are important measurements to get to the displacement of the boat, which is cool because we don't then have to pick the boat up with a crane. Right? There are some systems, the guys in England in the IRC system, their solution to this is to pick the boat up with a crane and weigh it. Well, I don't see any cranes out here that can easily pick a boat up with a calibrated crane scale and get that weight. It's not an easy exercise. But this can be quite easy. You need to have flat water and no wind, so the weather is a factor. But this is a very quick way of determining what the displacement of the boat is. It's also quite accurate. Our measurement criteria, as Zoran would tell you, is to measure within 2 millimeters. If you can measure the freeboards within 2 millimeters, it's within the same tolerance of a calibrated crane scale. 0.05%, right?
And you need, but we will talk more about this in the measurement seminar. We will show you some device that can help of you measuring this properly.
But the point is, this is a super accurate way to do it. And it's versatile. So, for those of you, who's doing the championship? Are you guys doing the championship from July? Everybody? Yeah? Okay, so what's going to happen, those of you doing the championship, you'll need to have your boat measured. Got to have your boat measured going through these exercises. And then guess what? If you do well,